Good morning, ladies and gentlemen. Today we're going to review the geometric definitions of the trigonometric ratios. So the trigonometric ratios have been around for, golly gee, probably 1500 years before Christ. So it's certainly not a new concept. And we are about to embark on this class M137 trigonometry. And before we get into the formal study of trigonometry, it's going to be a good idea to review these geometric definitions of the trig ratios. Most geometry courses introduce you to the geometric definition of the trig ratios, so it may be a good time to review this because we need a foundation in the geometric definitions before we embark on this journey that we're about to take. So, in geometry, you're going to consider this right triangle ABC, where the measure of angle C is 90 degrees. So here's your 90 degrees here. That angle, 90 degrees. And we have our other complementary angles, A and B. In A and B, the three angles of a triangle add up to 180. So A and B must add up to 90. It's a good point. We'll use that in a little bit. So the definitions of the trig ratios. The first one, a common one, is going to be this sine, S-I-N-E, the sine of A. And the parameter of the trigonometric ratios will always be an angle, i.e. when you're going to have to sine an angle, and A is an angle. And we're going to abbreviate that, S-I-N. So we're not going to say this is sin of A. We're going to call this sine of A. And the definition of the sine of A is simply the opposite leg divided by the hypotenuse. So the opposite leg divided by the hypotenuse. So the opposite, and I have opposite of angle A is lowercase a. The opposite of angle B is lowercase b, and the hypotenuse is lowercase c. So the sine of an angle is going to be the opposite leg divided by the hypotenuse. It really is that simple. And this cosine of A, abbreviated COS of A, is simply going to be the adjacent leg, the leg here next to A. This is the adjacent, this leg is adjacent to the angle A, divided by the hypotenuse. So the cosine of A is the adjacent leg divided by the hypotenuse. And the other trigonometric ratio we're going to study right now today, review, is going to be what we call the tangent of A. And the tangent of A is abbreviated TAN. And that's the tangent of the angle A is going to be the opposite leg, the leg opposite A, divided by the leg opposite of A, which is A, divided by the adjacent leg B. So those are the three basic trigonometric ratios we're going to talk about today. And we want to be able to pronounce these appropriately. This is sine of A. Let me go yellow here. This is cosine of A, and this is tangent of A. Fairly straightforward. Okay, and then so there's this mnemonic out there, this SOHCAHTOA. I don't use it a whole lot, but it's just a way to memorize these ratios. So the sine, this is sine opposite over hypotenuse. Cosine adjacent over hypotenuse. The tangent is opposite over adjacent. I don't use this a lot of my classes, but a lot of students think, oh, this is an easy way to memorize this. And then you can abbreviate that, or you can write it all as one. SOHCAHTOA. So if you want to use that, fine. If you don't want to use that, you certainly do not have to. So these are our basic definitions, the geometric definitions of the trig ratios, which will change and down the road for us in this course of trigonometry. Okay, so let's go to the second slide here. And let me do whoops. This is the guy that I want right here, okay. So same angle, but what we're going to do, or same picture, but what we're going to do is now we can also find the sine, cosine, and tangent of this complementary angle to A, which is B. Okay, and then the sine of B is still going to be the opposite leg of B divided by the hypotenuse. And the opposite leg of B is going to be lowercase b divided by C. The cosine of B, and we don't call this cos or cos or whatever. We actually call this cosine. This is cosine of B. Again, we're going to use the same definition. It's going to be the adjacent leg to B. And the adjacent leg to B is this guy right here next to B. And that's A divided by the hypotenuse. So the cosine of B is going to be adjacent leg divided by the hypotenuse. And the tangent, the definition doesn't change. The tangent of B is going to be the opposite leg divided by the adjacent leg, B over A. So in geometry, you can only find the sine, cosine, and tangent of angles less than 90 degrees because they only deal with right triangles. This again will change for us down the road, but it's an imperative for us to understand these geometric definitions of the trig ratios. So let's go to another slide and let's find some actual trigonometric ratios. So here's a simple triangle right here. This is your 3, 4, 5, probably one of the more familiar or common right triangles, the 3, 4, 5. And we know it's a right triangle. We know it's a right triangle because 3 squared plus 4 squared is equal to 5 squared. And this, of course, is the Pythagorean theorem. And we're going to use the Pythagorean theorem down the road as well. The Pythagorean theorem. We are going to use that down the road later on in this video. So we know this is a 3, 4, 5. We know it's a right triangle. These definitions only work for right triangles. So if I use my definition, if I want to find the sine of A, the sine of A, let's see here. The sine of A is going to be the opposite leg over the hypotenuse. Oh, okay. So the opposite leg of A is 3. The hypotenuse is 5. Easy peasy. The cosine of A is going to be the adjacent leg. Let's see here. Oh, the adjacent is 4 divided by the hypotenuse of 5. And the tangent of A is going to be the opposite of A divided by the adjacent here. So this is going to be 3/4. Easy enough. Okay, so let's get over here and let's do the sine of B. So the sine of B, let's see, is going to be the opposite of B, which is 4, divided by the hypotenuse, which is 5. And let's see here, the cosine of B, oh, it's going to be the leg adjacent to B, which is this 3 guy, divided by 5. Hypotenuse of 5. And the tangent of B is going to be the opposite over adjacent. Oh, okay, so that's going to be 4/3. And one thing that I want you to observe, and this is going to be an important property of trigonometric ratios down the road, is that if you notice, the sine of A is equal to the cosine of the complement of A. So A and B are complementary angles. A and B are complementary angles because the measure of angle A plus the measure of angle B has to equal 90. So the sine of A is going to equal the cosine of the complement of A. And that's always going to be the case. In like manner, the cosine of A is going to be the sine of the complement of A. 3/5 is equal to 3/5, so the sine of A is equal to the cosine of B because A and B are complementary angles. The cosine of A, which is 4/5, is equal to the sine of B, which is 4/5, because A and B are complementary angles. Important to note. something in a regular geometry class they would point out, your geometry teachers would point out. Okay, so let's do another example here. Let's go to the next slide and do another example. So here I have, so here I have a triangle, a right triangle, because this is right angle. But I have a missing leg here. I have a missing leg. So how would you propose to find the missing leg? We're simply going to use the Pythagorean theorem. And we know that 3 squared plus x squared is equal to 6 squared. And that's the Pythagorean theorem. And so now we have x squared is equal to 36. 6 squared is 36. 3 squared is 9. So 36 minus 9. So x squared is equal to, and what is 36 minus 9? It's going to be 27. And if we want to find x, we're going to square root that rascal. So x is going to be the square root of 27. And here's an interesting, why is x only equal to the square root of 27 and not the positive negative square root of 27? Because if we were in a geometry class, and over here, if I was in an algebra 2 class or an algebra class, and I said x squared is equal to 27, x would equal to the positive or negative square root of 27. That's a fundamental property of an algebra 2. The reason for this, the reason why x is only equal to the square root of 27 is because we're dealing with lengths. And x is a length. X is a distance, and distance is always positive. So we have to remember that with right triangles. So now we do want to simplify this. When we do these problems, we want to simplify these square root guys. And we learn that the square root of 27 is the square root of 9 times the square root of 3, because 3 times 9 is 27. And we know the square root of 9 is 3. So x is going to be 3 square root of 3, because the square root of 9 is 3. So the square root of 27 is 3 square root of 3. So we have this guy right here. I'm going to write this in here. And this is a review also. This is a Pythagorean theorem review. And now we can go ahead and find these trigonometric ratios. So the sine of A is the opposite over the hypotenuse. So the sine of A, we really didn't need that yet, is 3 over 6. And we can simplify that as to 1/2 if we want to, and we should. Now we will need this new distance that we found. So the cosine of A, so the cosine of A is going to be the adjacent, which is 3 square root of 3 divided by the hypotenuse 6. And we're going to simplify that. 3 divided by 6 is 1/2, so we can write that rascal as square root of 3 over 2. Okay? Heck, and while we're at it, we might as well find the tangent of A as well. So the tangent of A, let me go black here. The tangent of A is going to be the opposite, which is 3, over the adjacent, which is 3 square root of 3. And especially in this class, we don't want square roots to be on the bottom. So the first, we're going to move this guy up front, up top side. But the first thing I want to do is I'm going to write this. I'm going to cancel the 3's. This is 1 over the square root of 3. And I think we did have some review of simplifying radicals and making sure that there are no square roots on the bottom. And the way I'm going to do this is I'm going to multiply this guy right here by 1. And 1 is going to take on the form of square root of 3 over square root of 3. And the reason why I did that, because square root of 3 times square root of 3 is 3. So this is going to equal square root of 3 over 3. So that's what the tangent of A is, square root of 3 over 3. So when we do these problems, we don't want to have square roots on the bottom, nor do we want to have square roots that are not simplified. And the simplified square root is where the number underneath the square root symbol has no perfect square factors. Okay, so now we have found the sine of A, easy enough, the cosine of A, and the tangent of A for this right triangle. So let's jump to another problem. Keep in mind, if you're having trouble keeping up, you can always pause the video. Let's go to another slide here. And here we have, oh, okay. Oh, I have the angle. So what we're going to do here, and this is actually a standard or a topic that they want you to be able to do for this M137, and this is called, let me see if I can make this, see what, yeah, that's good. What they want you to be able to do is to solve a right triangle. Solve a right triangle. Okay, so solving a right triangle means to find all of the distances, find the length of the hypotenuse, the length of both legs, and the measure of the two angles. Well, the easiest thing for us to do right away is to find the measure of angle B. And we see that the measure of angle B, I'm going to write appropriate. The measure of angle B is simply going to be 90 minus 37. And 90 minus 37 is going to be 53 degrees. So the measure of angle B is going to be 53 degrees. And that was easy. So now we have to find X and Y. So how are we going to do that? We're going to use trigonometric ratios to find the measure of the length of X and Y. So which one did I come up with? Oh, here you go. The sine of 37 is going to be the opposite leg, opposite to 37, divided by the hypotenuse. And we're given that this leg is 4. So the sine of 37 is going to be 4 divided by y. And I want to find y. So what we're going to do, I'm going to do some quick algebra here. Well, the first thing I'm going to do is I'm going to go to my scientific calculator. I'm going to make sure my scientific calculator is in degree mode. Down the road, we're going to be talking about radians soon, but right now we're going to talk about degrees. So if you take your scientific calculator, make sure it's in degree mode, you're going to see that the sine of 37 degrees, and we always want to round everything to 3 decimal places. And we can truncate or round up, but we want 3 decimal places. So the sine of 37 degrees via the scientific calculator is 0.602. Just go to your scientific calculator, find that sine button, 37 degrees, bam, 0.6018. I round it up to 0.2. So now I have 0.602 is equal to 4 over y. Well, how do I solve for y? Well, what am I going to do? I'm going to multiply both sides by y to get that y out of the bottom. Then I'm going to divide both sides by 0.602, 0.602. These cancel, these y's cancel. And what are you going to have? You're going to have y is equal to 4 divided by 0.602. And again, I'm going to get my scientific calculator out, and I'm going to see that that is going to be 6.647 rounded up to 3 decimal places. I want to find the measure of, that's y. Now I want to find the measure of x right here. I want to find this x2. I could use this value. I can use either of the trigonometric ratios. I can use cosine, I can use tangent, or I could even, since I know this other length, since I know this, the 6.647, I could actually use the Pythagorean theorem to find x as well. But you know what? I like to use trigonometric ratios. So what am I going to do? I'm going to use the tangent of 37. Let's see, how do I get over here? Oh, let's see here. I think I zoomed out too much. I don't know. Yeah, so I'm going to use the tangent of 37, which is going to be opposite over adjacent. So the tangent of 37 is 4 divided by x, and x is this guy I want. And again, I'm going to multiply both sides by x. I'm going to do some quick algebra and divide both sides by tangent of 37. And you're going to see that, I can't zoom, get rid of, let's get rid of that guy right there. There you go. The tangent of 37 is 0.754. If I take 4 divided by 0.754, that's going to be 5.308, and that's what x is equal to. Okay, so now we have solved this right triangle because I know what x is, I know what y is, and I know what the angle b is, the other angle is. Okay, and we're about to finish this video. So one more thing that I want to bring up is in this course of trigonometry, we are going to use, instead of angles being labeled uppercase letters, it's going to be more common to use these Greek letters to represent, let me zoom in here a little bit, to represent angles. And so here we have the Greek letter theta. This is theta. It's spelled Theta. Horrible penmanship there. That's theta. And this guy here is alpha. Looks like a funky A. And this is spelled Alpha. So we're going to use those rascals for this most of the time. These Greek letters for angles. And again, it's going to be, these are the same geometric definitions of trig ratios. The sine of theta, opposite over hypotenuse. The cosine of theta, adjacent over hypotenuse. Tangent of theta is the x over y. Oh, and I had that wrong. Good deal. That's great. I love to make mistakes. That way I can correct myself. So the tangent of alpha is going to be x, the tangent of theta, excuse me, is x over y. Okay, so that's going to finish this video. It's a little video of the geometric definitions of the trig ratios, and we will see you soon.